point, we've done, worksheets 4, 5, and number 1 updated. Anybody has questions from anything that we've done so far? We'll start with some of those. Nicole?
Number 10 on worksheet 3.
Okay. Worksheet 3. Did we assign worksheet 3?
No. 4 and 5.
Are you talking about this one?
Yeah.
Okay. That's the problem? Okay. Okay. So, first thing we want to do is identify our values for A, C, H, and K. What is our A? -2. What is our C? 1. Notice the leading coefficient on the X is just 1, so the C is 1. Great. What's the H? You're very close.
-2 over 3 pi.
Nope. You're closer before. It's positive 3 pi over 2. Remember, the H is always the opposite of the sign it looks like in the equation.
Okay.
And then the K is 0. Excellent. So that tells me the amplitude is the absolute value of A, so that's 2. The midline is y equals K, so that's y equals 0. The period is 2 pi times the absolute value of C, so that's going to give me 2 pi. And the frequency is always just the reciprocal of the period. So I'll write my transformation map here. So that's Cx, well, C is 1, plus H, and then AY plus K. My key points for cosine are the following. Where am I getting these things from, Mr. Kulik? Yeah, I'm looking at my reference points chart at cosine. So we go and we do this. So 0 plus 3 pi over 2 is just 3 pi over 2. -2 times 1 is -2. Pi over 2 plus 3 pi over 2 is 2 pi. And then 0 times -2 is -2. Pi plus 3 pi over 2 is 5 pi over 2. And then -2 times -1 is 2. 3 pi over 2 plus 3 pi over 2 is 3 pi. And then 0 times -2 is 0. And then 2 pi plus 3 pi over 2 is 7 pi over 2. And then -2 times 1 is -2. So far, so good. I go back to my picture here. So this is, if this is 1 pi and that's 0 pi, this is a half. So this is 3 pi over 2. And then -2 is there. And then I have 2 pi and 0. And then I had 5 pi over 2 and 2. And then 3 pi and 0. And then 7 pi over 2, -2. So that's my points plotted. Let's go ahead and extend this graph. So if I continue on the pattern, the points I would draw are those ones, right? So I'll just draw in my curve then. So it looks something like that. And we're good. You happy? Yeah. This is from worksheet number 1. I've not assigned it as of today. Okay, well, did I make a mistake? Okay. For the problem set number 2, the one that's due for next weekend, I listed, it says chapter 3, worksheet number 1 updated. When I look at it at my end, for 929. That's delta math. And then for problem set 1 from chapter 3, I just list worksheets 4 and 5. I don't think I've assigned 3. Am I wrong on that? You can show me what you're seeing in a minute.
On the agenda, it says,
Oh, on the agenda, did I put it in the wrong? Now that's possible. Let me look here. Yes, so I guess I did do that wrong. I'll fix that.
Mr. Kulik,
Yes,
did
sir.
you assign worksheet 1?
Yeah,
Okay, and can I use that?
yeah. So that's my fault there. Troy, I apologize on that. Okay. So that was from last week's agenda, right? Ay, 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 Mr. Kulik. I'll fix that in the other sections. Thank you for pointing that out, though. Like, helps to have that all straightened out, right?
yeah,
Okay, so that should be the reflect. What we're seeing on My Notre Dame should match now what's on the schedule.
do I just like erase it or rename the,
What?
are we gonna do this in the future? Or do I just like scratch it?
You might as well hang on to it. I'm not sure
All right.
what'll be assigned. All right. It's one of those things we just got to kind of see how things go. You know what I mean?
Yeah.
So it's there if I need it. All right. Other questions from homeworks? From anybody else? Okie dokie. So today we're going to start section 3.2, where we're going to be talking about the tangent function. So in section 1, we talked about sine and cosine. We talked about how to go from graph to equation, how we went from a description of the graph to an equation, and how to go from equation to graph. Those were the 3 skills we did in section 1. We did that with sine and cosines. In section 2, we're going to do kind of the same things, but except we're going to use the tangent function. And we're not going to do the description. It's just going to be graph to equation and equation to graph. So there won't be any description problems with tangents. Okay with that? So let's first take a look at what the regular old graph of tangent looks like. Put that in here. Yeah, I hate that. Hold on a second. School like you can do better. That'll look a lot nicer. All right. So there's our picture of the graph. What do you notice about how this is different than sine and cosine? Well, it's not a wave anymore, right? It's not like that sinusoid shape where it's just going up and down, up and down, up and down. Although it is repeating itself over and over and over again, right? So one of the new things about the graph of tangent is that it appears to have, like, it doesn't connect together. It's discontinuous, right? So each of these like sections of our graph seems to be like broken at a predictable place. What do we call a vertical line like this that the graph approaches but doesn't cross? Remember what those things are called from last year in your Algebra 2 class? Those are called vertical asymptotes. How many vertical asymptotes is the graph of tangent going to have? What do we think? Think about it for a minute. It is infinite, Kiara. Thank you. Yes. It's okay to celebrate, right? Because the graph keeps going on forever, and we're going to keep getting them forever, right? Is everybody okay with that idea? Now, if I look at my graph, this is like one cycle of my graph, right? You guys agree with that? That cycle appears to begin at negative pi over 2 and end at positive pi over 2. What do you notice that that period is then, if we're starting at negative a half pi and ending at positive a half pi? Pi. Ooh, that was different than sine and cosine, right? Now we still have a midline for a tangent graph, right? If we want to draw a line that splits the graph in half. Ooh, boy, that got away from me there for a minute. So they still have a midline, but we're not going to have any amplitude because is there a maximum or minimum value for this function? No way, Jose, because the graph keeps going up forever and keeps going down forever, so there's no biggest or smallest points involved, so there's no amplitudes. Is everybody okay with that? But we still have a midline, we still have a period. So let's write down that formula for us. Okay, do I not have that in here? Whatever, write it out then. All right, so if our function is y equals a times tangent 1 over c times x minus h plus k, we have that our midline is y equals k. Our period is pi times the absolute value of c. And our frequency is still 1 over the period. The only thing that's really different about those features is the formula for our period is different now for than it was for sine and cosine. You guys see that? What was the period formula for sine and cosine? 2 pi absolute value of c as opposed to 1 pi absolute value of c. Everybody's cool? Okay. Additionally, we've seen that our graph of tangent has vertical asymptotes attached to it, and it has no maxes and mins, right? Now, we still have a midline point. Right? Where the graph crosses the midline. Everybody's okay with that? But we don't have any extrema, any mins and maxes. So far, so good? All right. So let's do some examples of going from a graph to an equation. So, just like before, we have our general form equation. So we need to find our values for A, C, H, and K. Just like we've done before. So what I'm going to do is I'm going to start by looking for the midline on this graph. Can anybody tell me where the midline is? Y equals...
-1.
Do you guys agree? Looks right to me. There's my midline. And what does that give me then? Nicole? K. So the K is also -1. Feel good? So far, so good? Now let's hunt for our period. For tangents, it's actually really easy to pick out a cycle because a cycle just goes from asymptote to asymptote, right? So if I look at this, that's one period from -π/4 to +π/4. So how far is a period? Over 2, right? I go 1/4, and then another 1/4 gives me a half. You guys agree with that? I start at -π/4, I go 1/4 to get to 0, and I do another 1/4 to get to π/2 or π/4, giving me a half pi total. A fourth plus a fourth is a half. Everybody so far so good? And the formula for the period is pi times the absolute value of c. Are you guys capable of looking at that equation and solving for c without actually having to do the solving? What does c have to be here? What's that? Okay, so C, we always pick the C to be positive, sure. What number, though? What if I think about pi over 2 as pi times a half? If we look at it that way, what does c got to be? This is me put down breadcrumbs.
Pi over 2.
So like if I look at this, I have a pi here and a pi there, right? And then I have a c here and a 1/2 there. What does it look like c has to be?
A half.
Yeah. Kind of see it now. It's one of those things like, oh, those are some pretty good breadcrumbs. I don't know how I missed it. It's okay. It's early. It's Monday morning. We're all not always on the tippy top of our game. So far, so good. Yes? Okay. Let's figure out the a next. So you notice on this tangent function we've drawn, we've given you that midline point and then 2 other points there, right? You guys see that? We also gave you the point pi over 8 comma 0 and then negative pi over 8 comma negative 2. Those points, well, really just one of them will be enough, but one of those 2 points I'm going to use to figure out the a. So this distance from that point down to the midline, or up to the midline, depending on which one you use, is going to be our absolute value of a. So how far was it to go from -1 to 0? 1 unit, right? Everybody so far so good? Now if I look at our cycle for tangent, notice how the cycle starts down and then goes to up. If I look at the graph of regular old tangent, that's the same thing we're seeing on our cycles, down to up. You know what that tells me? It tells me the sign for a. So the sign for a is going to be positive when our graph goes from down to up. If it goes from up to down, guess what it's going to be? Negative, yup. So far, so good. All right. And guess what how we're going to find the h? So our midline point should be hk. So the midline point here that we're given was 0, 1, or sorry, 0, -1. So what does h got to be? Just 0. It's cool, like that ain't too bad. So I have y equals tangent of 1 over c, so I'll do the reciprocal of 1/2, x minus h plus k. Right, so 1 tangent, 2 times x minus 0 minus 1. Or if I wanted to simplify this all down, like Mr. Kulik, can't I just write it as tan of 2x minus 1? Yes, of course you could. that would be fine. Seems like it's a lot simpler that way. Can I do it that time every time? Yes, of course. Please do. What do you guys think? Pretty similar to what we've done already, correct? Let's do another. So what I'm going to do right now is we're going to do 25 and 26 from the homework. This is part of the next assignment, so we're going to do these together right now. So if you need to move so that this problem is where you keep your homework and not where you keep your notes, that's why I'm telling this to you right now, so that if you're like, oh no, my notebook is unorganized and I want to move it, just so you know. Or it's like, oh, Mr. Kulik, I wish you have told me now and I have to recopy this or something. Okay. So I'm just going to drop in these two problems. And we'll zoom in a little bit here so everybody can see. All right. I'm going to put a timer on here for we'll go with, say, 10 minutes. Why don't you work on 25 on your own? At the end of 10 minutes, we'll go through it together. Okay, so that we may have this correct answer, but this will be part of the homework assignment. So if you want to do this on a paper where you can have your homeworks, it's okay if things are a little out of order on your homework paper. Mr. Kulik doesn't mind. If you mind, that's on you. But let's do this together and make sure that we feel pretty good about doing this. Plus, it's good review for any pending homework quiz where you might have to do something similar, right? Even if it's sine or cosine, it's still kind of the same problem, isn't it? Some of the rules are a little bit different, but it's like the same general idea. That's what I would have expected. Okay. Yeah. Okay. So, why didn't that work? It's unfortunate. Is anybody still plugging away at this? Okay. I still have 2 minutes on my stopwatch, but I saw a lot of people just kind of like staring blankly off into space. So give a couple more minutes here and then we'll get some people to help explain what we did here on some not so random choices. That is so strange. All right. Let's see here. Emily, oh, I'm sorry, Grace. Can you tell me the midline?
-2 or -1.
So you -1 would have been here, right?
Yeah.
That doesn't look quite right.
No. -3.
-3. So it comes in through that. Say thank you to page 2 there, or whoever was whispering in your ear. Okay, so what does that tell me K is then?
pi/2 with 3.
So the midline is y equals K. So what's K?
-3.
There you go. All right. Jackson, can you tell me the period? So the period is the distance between asymptotes. So if you're looking at that as a period, it's the distance from 0 to pi. So how far is that? 1 pi, though, right? Okay. And AC or H, what can I get from the period?
If you aren't using hormonal contraception, you
What
may.
the heck are you doing? Why did it... That was very strange. Cell phone, stop listening to me. What did it even think I said? Okay. AC or H, which one of those is the period going to get me? C is correct. What's the formula that I need to use? Okay. Does someone else remember that wants to help Jackson here? Nicole. Yeah, the pi absolute value C is our formula for period. So what does C have to be in this case then? Just 1. Jackson, you happy? I said, are you happy?
Yeah.
Okay. Joey.
Can I use the bathroom?
Sure. Ava, can you tell me A, or what we got for the absolute value of A here?
Might be
Yeah, so great. That's the distance from one of those other 2 points back to the midline. So my A should be then plus or minus 2. Which one do I want, the plus or the minus?
plus.
Plus, very good. Why?
It's like down.
Because it goes down to up as we read the graph from left to right. Great, thank you. Brody, what's our midline point here that we'd be using?
It's just y. Yes.
So we need the point though, so we need the x. And what is that midline point going to give us?
H.
H, good. And what is the h then? Pi over 2. Just the x coordinate from our midline point. So if we put this all together, y equals a tan of 1 over 1 x minus pi over 2 minus 3, or we could just simplify this down to y equals 2 tan x minus pi over 2 minus 3. So again, if you need to add in some extra stuff because you didn't have it quite all the way there, you want to do that now, that's fine. But this is also in your notes, right, in the content library. So if you need to go back and get this when you're filling in your homeworks, that's fine too. All right, same story, different problem. Ready to go? See if Siri still wants to talk to me about hormonal contraception for some reason. I don't even know what I could have said. Nor do I think I had Siri turned off, so she wasn't supposed to be listening to me, but apparently Apple just does what it wants, right? So same deal, new problem, doing the same thing. I'm going to do the same thing after, so if you haven't been called on yet, I would definitely want to make sure that I have tried hard here so that I don't get, if I do get called on, I have something to say. You know what I mean? So strange. Why is it doing
Okay, so even if it wasn't this way, it's still means all I got. One, two. One, two. You know what you jump square, so what's 3 pi? That's not the right number. 3. Oh no.
Okay, that's our 10. Here we go. New set of non-volunteer volunteers. Gavin, can you tell me what the midline is? 1, that's correct. So what value does that give me for ACH or K? K, what is K then? Perfect. Francis, can you tell me what the period is? Good. And what else what letter can we get from the period? A, C, H, or K? Perfect. And what's the formula that I'm going to use to solve for C? equals pi over 2. Perfect. So the c should have come out to be? No. The c is 1/2, right? If you reminding you guys, this was like the same thing that we saw in that first example I gave you, right? Pi absolute value c equals pi over 2, and the c was 1/2. Same thing happened here, but good, Francis. That was, you gave almost all the way there, which is great. Jenna, can you tell me the A?
Is it -3?
So, okay, so the absolute value of A you're saying is 3, which is correct. And you're saying A is -3 because we're going from up to down instead of down to up. Perfect. That looks good also. And then, Emmy, can you tell me the midline point that we want to consider?
I said pi over 2.
Comma 1, right? We need the whole point. And the H then is going to be pi over 2. Fantastic. So 1 over c I'm just going to write as 2. So there's our answer, right? What do you guys feel on these?
How did you find the answer?
So the A, the absolute value of A is going to be the distance from one of these two other given points back down to the midline. So if we're going we're going from 1 to 4, that was 3 units. And then we decided it was negative because the graph goes from up to down instead of down to up. How do you guys feel here with this stuff? Not too bad, right? Pretty similar to the things that we've done. If you're up and pretty current through the homeworks 1 and 2, I'm sorry, with worksheets 4 and 5, you should have felt pretty good on that, right? So far, so good. Okay. I think that's probably good for what we want to do today. Oh boy, I did the wrong order here. Troy's going to be mad at me again. So we've done we actually did the part 2 today. Kira, what's up?
Oh, I was just saying.
Oh, okay. That's fine. How's your volleyball season going?
Good.
Who'd you guys play this weekend?
I forgot. Yeah, we played 5 schools.
5 schools. How did you do?
We lost 1.
But how did you do?
Oh, I did.
You did good.
I think, yeah.
It wasn't your fault.
Oh,
The one loss.
yeah.
Okay. I don't know. We're just talking. I tried to call on you and you didn't say anything. Didn't have anything. You were just stretching, so I thought I'd just make a conversation. you know, just trying to do stuff. All right, so the good news is the assignment for what we did today was 25 and 26. Guess what we're already done with? I know you're disappointed. It's like, man, I really wanted more homework. So probably, unfortunately, can't help you out too much there. What I will do is give you guys a delta math that we can work on. So if you look at chapter 3, delta math number 2 will now be visible to you. And what we're doing here is just going to be more practice, just kind of going from graph to equation using sines and cosines.
Not all we have to do.
So there's 3 types, but it's just like the same kind of problems over and over again. So I think they're going to get like a little bit more complex each level up you go. So instead of having just like one thing or 2 things, they might have 2 or 3 or 3 or 4 of the ACHs and Ks. But it's going to be just like what we've done in the homeworks. And then as a reminder, what haven't we done yet this chapter? Homework quiz. What should you be looking for still this week? That homework quiz, right? That will be happening sometime this week. We didn't do it today. There's only 2 more chances left. So far, so good. What is that homework quiz going to be covering? And the graphing piece. So if we're talking about the graphing that you would have done in worksheet 1 updated, and then the 4 and 5 worksheets. Yep. So those problems would be what you should be expected to do. No. It will not. Although the stuff we did today is remarkably similar to the stuff you did in like worksheet 5 or whatever, right? So it's kind of still almost the same, but there won't be any tans on it. Deal? Sounds good, Mr. Kulik. All right.